Let's talk about graphing transformations when we're given a graph that's not one of our basic parent functions. Sure, we could do the same thing we did before, where we stretch or shrink, make it wider, thinner, left or right, and up and down, but it's a little bit harder when you don't have a function that's centered at the origin. So you can continue doing those. You can continue to make it 2 times taller and move it up 3, or you can look at specific coordinate points. So we're going to graph the transformations of f of x in all 5 of these examples, and this is our starting f of x function. When we do this, it helps to pick out some of your major coordinate points. So I see that we have, I'm going to just make a little table, 0, 0, 3, negative 2, and 4, 1. These are my starting coordinates of my original function. Okay, we're going to graph 2 f of x. Remember, f of x is the same thing as y. So this is 2y. So we're going to take those 3 coordinate points, but we're going to multiply our y values by 2. So 0 times 2, negative 2 times 2, and 1 times 2. Leave your x values the same. Don't change them. And now I'm going to plot these 3 coordinate points. So 0, 0, 3, negative 4, and 4, 2. If I had a ruler, I would connect the dots nice and smooth, but you get the general idea. Notice that it's stretched my graph 2 times taller. Same idea, we're going to do the same thing here. This f of x is the same thing as my y. So I'm just going to multiply my y values by 1/2 and then add 3. So I'm going to rewrite my table. X values stay the same. Multiply y times 1/2, so 0 times 1/2. Negative 2 times 1/2, and 1 times 1/2. I have to do it in 2 steps because I will mess up otherwise. So I'm going to multiply my y values by 1/2 and then add 3. So 0 plus 3, negative 1 plus 3, and 1/2 plus 3. Okay, that's my intermediate step. So these are the 3 coordinate points I'll plot. 0, 3, 3, 2, and 4, 3.5. All right, connect the dots and you'll see, it's kind of hard to see because my coordinate grid didn't show up, but the graph should look not quite as steep and deep and high, and the vertical transformation here is smaller, and then of course the whole thing's been moved up 3 spaces. Right, what do we do if we have something inside our parentheses now? This is with my x, so I'm going to be transforming my x. If you remember when we did our transformations earlier, everything inside the parentheses here was backwards from what we expected. We're going to have the same exact issue here. So it says multiply your x's by 2, but actually we want to divide them in half. Multiply by 1/2 or divide by 2. I guess I should have written divide by 2 just to be like a little more straightforward. So instead of multiplying by 2, we're going to divide our x values by 2. So 0 divided by 2. 3 divided by 2 is 3/2 or 1.5. And 4 divided by 2. Your y values stay the same because I don't have anything in front or added to the end. So keep them the same from our original function. And now plot these 3 points. 0, 0, 1.5, negative 2, and 2, 1. So if you notice, this graph has just been squished in like a spring tighter. All right, what if we have a 1/2 here? I am going to still do the opposite. It's with my x values, so the x values are what's going to change. My y values are going to stay the same, but I'm going to be dividing by 1/2. So I'll have x divided by 1/2. If you do keep, change, flip, this is the same thing as multiplying by 2. So either divide each of these original numbers by 1/2 or just multiply by 2. It's the same idea. So 0 times 2, 3 times 2, and 4 times 2. I'll plot these coordinate points, and of course, I don't even have room for them. It would be somewhere like this. but you can see that the graph is stretched out way more. Okay, so anything inside your parentheses goes backwards from what you expect. Anything in front of your f of x or added to the end is just straightforward. So let's do an example where we have multiple things going on. I have this 3 in front of my f of x or my y value, so I'm going to take my y values and multiply them by 3. I also have this x minus 1 in the parentheses, but it's in the parentheses. Inside the parentheses is backwards from what you expect. So instead of minus 1, I'm going to add 1 to every single x value. So reminder, these are my starting coordinate points, so I'm going to add 1 to these. 0 plus 1, 3 plus 1, 4 plus 1. And these are my original y values. I'm going to multiply them by 3. 0 times 3, negative 2 times 3, 1 times 3. And these are the 3 points I'll plot. So 1, 0. Oh, that's not 1, 0. Go over 1 and up 0. 4, negative 6 is way down here off the graph. And 5, 3 would be here. So my whole entire graph has been stretched way taller, and it's been moved right 1. So for all of these, anything in front, you're going to multiply with your y values, so a y plus k, straightforward. And then anything inside your parentheses, you're going to do the opposite of. So I would divide by b in this case and subtract h, and you'll do that to your x values.